Hey everyone, how's it going here? Just gonna go through a quick mortgage problem that I put together. I used prior tests and assignments that were available to the students at the time, and I try to cover everything that you would need in case you encountered a mortgage problem. So we can start off by just reading the question here. It's available in the description below. You can just download the link there and you can read along with me, or you can pause the video and read it now. So you're planning to buy a house in Toronto that has a price of $1 million. The bank has offered you a quarter road of 4% compounded semi-annually. You have enough saved up for a down payment of $300,000, which means your loan will be $700,000. The amortization period will be 25 years and the term of the mortgage will be 5 years. You're going to be making monthly payments on your mortgage, and payments will be made at the end of each month. So the first part of this problem is to prepare a mortgage amortization schedule. For the first two parts of A, we're not going to need it, so I'm just going to go through the question, and then later on I'll tell you when you would require an amortization schedule. So the inputs here on the left hand side, you can see the price of the home is $1 million, the down payment is $300,000, therefore the loan amount is $700,000. The quoted rate of interest given by the bank is 4%. The amortization period will be 25 years. The number of payments per year is 12, and we're going to need that when we solve for our EAR. The beginning and end is 0 because the payments are being made at the end, and that's how Excel determines if it's a beginning or an end payment. The future value will be 0, and the total number of payments will be 300, which is found by simply multiplying 12 by 25. The number of times the interest is compounded yearly is 2 because it's semi-annual, and we're going to need this to solve the EPR. So to find the EAR, what you're going to have to do is you're going to have to do 1 plus the quoted rate divided by the number of times compounded per year to the power of the number of times compounded per year, and all of that minus 1. Once you find your EAR, you can simply find your EPR by going 1 plus EAR to the power of 1 divided by the number of payments per year, and then all of that minus 1. To find your payment amounts, you're going to use the payment function in Excel. Your rate will be your EPR that you found. So just reference all the cells when you're doing this. So as you can see, the rate is referenced as the EPR, and then the number of periods is referenced as the total number of payments here is 300, and then your present value is the loan amount, the future value is 0, and the type is 0 as we determined earlier. So if you just go ahead and enter that in your cell, you get an answer of 3,682. That's going to be your monthly payments of the mortgage. So that takes care of the first part of A. Now the second part of A, how much will you pay in total over the life of your mortgage? In order to find this, we're going to have to multiply the period payment that we found prior by 300. So this will tell us the total amount that we paid to the bank over the life of our mortgage. That's a relatively straightforward question, and you just simply multiply the two numbers. So the third part of A, over the length of the entire mortgage, how much will you have paid in interest? In order to do this question, we would have to set up an amortization schedule. As you can see, I already have mine set up here, but for those of you who are unfamiliar with the amortization schedule, I can just quickly show you how you would go about doing it. So you would enter your payment number, which is the first one. The principal amount, which is the amount that we're taking out initially, is 700,000. The payment amount, you can just reference back to the original cell right there. Make sure you make it an absolute reference, because when you do drag the cell down all the way, Excel knows that you want to keep your payment consistent. So your interest component is going to be your principal amount at the beginning of that specific period times your EPR that you found. Make sure you make an absolute reference for your EPR. And then your principal component of your period payment is simply going to be the entire period payment that you're paying minus the interest component of the period payment. And that's going to give you 1368. So at the end of the first period, which is going to be the first month, the principal amount at the end of the period is going to be 700,000 minus your principal component of the period payment. So basically what you're doing is you're paying 3,682 every month to the bank. The amount of interest that you're paying is dependent on how much of the loan is outstanding. So in this case, it's still 700,000. We multiply the APR by that, and we got our interest component of the period payment. Once you pay off the interest component of the period payment, the remaining is going to be paid off. The remaining amount is used to pay off the principal amount that was at the beginning of the payment. So to do the second line, you're just gonna put payment number 2. Usually what I like to do is I like to put the 3 payments and then I'll just drag everything along, because if you only put the first payment, since the 700,000 is manually inputted, Excel won't be able to do the calculations. So you just reference back the principal amount at the beginning as the prior ending principal amount. So in this case it's 698,000. Then your period payment is consistent, so we can just drag that along, and because it's an absolute reference, Excel knows. The interest component as well, you can drag down. You can drag down your period payment, and this can be dragged down as well. So as you can see, I believe if you drag down this, yeah, so it automatically fills everything in. So what you would do now is you would drag it all the way down to the 300th payment, because it is a 25-year mortgage and there are 300 periods in that mortgage. So once you're done, your table should look something like the one I have on the left-hand side here, all the way down to 300. And then from that, you can figure out the total interest paid over the life of the mortgage by simply using the sum function in Excel. So what you do is you reference a certain range in your amortization schedule. So, So, for example, you have the sum of the first payment, the sum on the first payment for your interest component, and then it's going to go all the way down to the 300th payment. So you don't have to scroll through, you can just type in the range. So for example, you just find where the last interest payment will be on the 300th payment, and you would just simply type in the reference right here into the cell, and then you press enter, and then Excel adds everything up and it gives you a final answer right there. So the fourth part of A, how much principal will you have paid off during the initial term? Again, if you have an amortization schedule set up, this is very simple. You use the sum product again, the sum function again, and you would only highlight, I don't know why it keeps doing that. Sorry. You would only highlight the payment from the beginning, so the first payment, all the way down to the 60th payment, because you want to determine in total how much interest you paid to the bank during the initial 5 years, which is 60 periods, because there are 12 months per year for 5 years, and that equals 60. So once you press the sum function, it'll give you an answer of 90,000. So the fifth part of A, at which payment does more than 50% of the payment go towards the principal? If you have your amortization schedule set up, this is very simple. You just scroll down until you see that the principal component of the period payment is just slightly greater than the interest component. So at the 91st payment, we know that we are paying more towards our principal than paying interest towards the bank. So the 91st payment is the point at which more than 50% of the payment is going towards the principal. Okay, so now to do part B of the mortgage problem. Assume now that you have decided to make additional monthly payments of $100 during the initial term of your mortgage. How much less do you owe the bank after 5 years? So you can just copy down the amortization schedule that you just made prior. That's what I did, and I find it to be the easiest way to do this kind of a problem. You're going to copy down everything the same, except the only difference now is your period payment is going to increase by 100. So make sure that you reference the new period payment and just drag everything down, and it should work out the same way as it did to the same way that the prior amortization schedule worked. But you're only going to go down to 60 payments because it is only for the initial term. That's all we care about. And then you're going to get a final principal amount at the end of this at the end of the 60th payment as 602,753, and you're going to compare that to the amount that you found in your original amortization schedule for the 60th payment. So in that case, it is right here. So you can see that it's slightly higher because when you do increase the monthly payment, you are paying the principal off faster. So we can see here that if you subtract the two numbers, as I did right here, you're going to get an answer of 6,624. So in the initial term of the mortgage, you owe this amount less to the bank. So to do part C now, assume now that at the end of the initial term, interest rates have increased to 6% compounded semi-annually. The amortization is now 20 years. What will be the amount of your new monthly mortgage? So basically for this question, you have to interpret it as if after the initial 5 years, the original rate that the bank was giving us at 4% is no longer available. Now they want us to pay 6% on the loan. So what you're going to do is you're going to continue the loan from the 60th payment, which we found right here, the ending balance, and then you're going to continue to amortize the rest of the loan. So what I mean by that is the value that we just found is going to be your new present value of the loan. Your quoted rate is 6%. Your EAR is different because the quoted rate is different. Your EPR is different also. So you just go ahead and solve it just like we did to the prior when we found the EAR and the EPR. The future value is still 0. It's still the payments are still being made at the end of the month. Now we have 20 years left because we have fast forwarded 5 years into the future, and there are 240 periods left because 60 periods have passed. So you can just go ahead and use the payment function just like we did prior. Now you just have now you have a new payment amount, and that's going to be the payment amount you're going to pay for the next 20 years unless there's a change in the rate. So now to do part D. Now we are interested in determining how the new monthly payment amount will change at the end of the initial term depending on the quoted rate of interest and amortization period. The possible quoted rate of interest will be between 4% and 7% compounded semi-annually. The possible years of amortization will be between 19 and 21 years. Calculate the possible monthly payments. So in order to do this question, it's best to make a table here. I already did the question, so I'm just going to clear it here. So you want to set it up like this. Make sure that in the top left corner you have your payment, so Excel knows what exactly you're trying to calculate. In the row above here, you're going to have your interest rates, and in the column here, you're going to have your number of years, the different variations. You're going to go ahead and you're going to highlight this whole area, and you're going to go to Data, What If, Data Table. You're going to change your row inputs to the quoted rate and your column to the number of years, and it should, yep, there you go. And a little trick that you can do here, you can just see that at 6% at 20 years you get 4,339, which is exactly what we calculated previously. That's just a little way to check that you've done your table correctly. And that's it. That's the entire mortgage problem that I have today. Thank you for watching, and I'll be sure to post more videos discussing different finance problems. Thank you.